Good morning students. So இன்னைக்கு நம்ம கிளாஸ்ல என்ன பார்க்க போறோம் அப்படினா tetraethylate. So tetraethylate, it is simply represented as TEF. So the formula of tetraethylate is C2H5 4 times lead. So next preparation. So it is prepared from ethyl chloride. This ethyl chloride reacts with the sodium lead alloy to form tetraethylate. So here 4 moles of ethyl chloride reacts with 4 moles of sodium lead alloy to form tetraethyl lead, and lead and sodium chloride is formed as the other products. So what is the uses of tetraethylate? It is used as an additive to petrol, which increases the active number of petrol and reduces the knocking property. So next compound is thioalcohol or mercaptans. The general formula of thioalcohol is RSH. So preparation. So first preparation is from alkyl halide. So ethyl chloride reacts with sodium thiol or potassium thiol to form thioalcohol. Here CH2CH2Cl reacts with sodium thiol NaSH or potassium thiol KSH to form thioalcohol, and sodium chloride or potassium chloride is formed as the other product. If you use sodium thiol means you get sodium chloride. If you use potassium thiol means you get potassium chloride. So next from alcohol. So ethanol reacts with phosphorus pentasulfate to form thioalcohol, and this phosphorus is removed as phosphorus pentoxide. Another reaction is ethanol reacts with hydrogen sulfide in the presence of thiourea as the catalyst. So ethanol is converted to ethyl thiol C2H5SH. So this OH is removed as water. So next reaction is from alkyl disulfide. So this is the methyl disulfide. It in the presence of zinc, it is a reduction process. So the sulfur bond is broken. One hydrogen added here, another hydrogen is added here to form 2 moles of methyl thiol. So next from Grignard reagent. So methyl magnesium iodide is a Grignard reagent. It reacts with the sulfur to form adduct. It undergoes hydrolysis to form methyl thiol and magnesium hydroxide iodide. So next from alkyl isothioureanum salt. So this isothioureanum salt is first prepared from ethyl bromide and thiourea. So the reaction is, so this is the structure of thiourea, C double bond S NH2 NH2. So this lone pair of electrons first shifted here. So here carbon nitrogen double bond is formed. This nitrogen gets positive charge. So what is the product? C double bond NH2 inge plus irukum NH2. So this bond making a bond between this alkyl group. So SC2H5. So C2H5 SC double bond NH2 plus NH2 Br minus. It undergoes hydrolysis to form ethyl thiol urea sodium bromide. How it is hydrolyzed? This is the structure of alkyl isothioureanum salt, that is C2H5 SCNH2 double bond NH2 plus. So here the bond is cleaved. So hydrogen is added here. So this part is converted to thioalcohol. This is the COH NH2 double bond NH2 plus. This is the enol form, which converts to keto form means you get urea. And the sodium takes this bromine atom, it is removed as sodium bromide. So next properties. So first property is reaction with metal. So the thioalcohol reacts with the sodium to form sodium salt of thiol. So C2H5SH reacts with sodium, C2H5SNa, and hydrogen is liberated here. Okay. So thiol reacts with the sodium to form sodium salt of thiol, and also hydrogen is liberated. So next reaction with metal oxide. So thiol reacts with mercury oxide to form mercury mercaptide. So here this hydrogen is removed as water, so this mercury is added here, so you get mercury mercaptide. So next reaction with acid. Already you know that acid reacts with alcohol to form ester. Here also acid reacts with thioalcohol to form thioester. So here this is the acetic acid, this is the thioalcohol. So water is removed here. So what is the other product? CH3COS C2H5. Thioester is formed. So next reaction with the aldehyde and ketones. So this is the acetaldehyde. Acetaldehyde reacts with ethane thiol. So here 2 moles of ethyl or ethane thiol is reacts. So this 2 hydrogen and this oxygen atom combines together to remove as water. So what is the other product? CH3CH C2H5 S C2H5 S C2H5. Thioacetal is formed. So reacts with the ketone. So the thiol reacts with the ketone. Here also water is removed. Here 2 hydrogen atoms are there. So this combines with this oxygen atom. It is removed as water. So what is the remaining? SC2H5. 2 moles of SC2H5 added to this carbon atom. So CH3C CH3 SC2H5 SC2H5. It is a thioketone. If the reactant is aldehyde means you get thioacetal. If it is ketone means you get thioketal. So next oxidation. So the thiol is oxidized by using mild oxidizing reagent, that is hydrogen peroxide, to form disulfide. C2H5 SC2H5. Disulfide is formed and water molecule is removed. Instead of hydrogen peroxide, you also used sodium hypochlorite. This is also mild oxidizing agent. Suppose we change the oxidizing reagent from mild to strong. So this is the strong oxidation. So nitric acid is act as a strong oxidizing agent. So it oxidizes thio to sulfonic acid. Here sulfur is oxidized to SO3 group. Okay. So thiol converts to sulfonic acid by strong oxidizing agent such as nitric acid. Okay. So next compound is thioether. So what is the ether or OR? So instead of oxygen, here sulfur is there. So it is called as thioether. So preparation from alkyl halide. So ethyl iodide reacts with potassium sulfide to form thioether, and this potassium is removed as potassium iodide. From second reaction is from ethers. So this is the diethyl ether, C2H5O, C2H5. This is the diethyl ether. So 5 moles of diethyl ether reacts with the phosphorus pentasulfide to form thioether, and this phosphorus is removed as phosphorus pentoxide. So next from thioalcohol. Thioalcohol moles of thioalcohol converts to in the presence of alumina and zinc sulfate. So thioalcohol is converts to thioether. Here hydrogen is removed. So hydrogen is removed means this is the oxidation. So C2H5 SH C2H5 SH. So this hydrogen is removed. Sorry. This is not oxidation. Here hydrogen sulfide is removed. Okay. So this is 1 mole of C2H5SH thiol. This is the another mole of ethyl thiol. Here hydrogen sulfide is removed in the presence of alumina and zinc sulfate. You get thioether. Okay. So fourth reaction is from Grignard reagent. So Grignard reagent, here ethyl magnesium iodide is used. It reacts with sulfur to form adduct. This is further reacts with alkyl iodide to form ethyl methyl ether, and this magnesium is removed as magnesium iodide. So next from mercaptides. So alkyl iodide, here methyl iodide is used. So methyl iodide reacts with sodium mercaptide to form ethyl methyl ether, and this sodium is removed as sodium iodide. So next property, so reacts with the halogen. So the diethyl ether reacts with the halogen to form diethyl sulfur bromide. Next reaction with alkyl halide. So the thioether reacts with ethyl iodide to form triethyl sulfonium iodide. So already it contains 2 moles of ethyl. Here one ethyl group is there. So both are combined, C2H5 thrice S plus I minus. The salt is formed. Here triethyl sulfonium iodide is formed. So next reaction with the metal salts. So next reaction with the metal salts to form coordination compounds. Here diethyl sulfide reacts with mercury chloride to form insoluble metal salt. So here sulfur has lone pair of electrons. It donates the electron to empty orbital of mercury atom, that is a metal atom. So it is a coordination bond. So the thioether reacts with the metal salts to form coordination compound. So next hydrolysis. So thioether undergoes hydrolysis to form alcohol. So here bond is broken, here also bond is broken. So hydrogen is added here, OH is added here. Again 1 mole of water molecule, hydrogen is added here, OH is added here. So this sulfur atom is removed as hydrogen sulfide. This ethyl part is converted to ethanol. So next oxidation. So diethyl ether undergoes oxidation in the presence of hydrogen peroxide. This is the mild oxidation reagent. Sulfur is oxidized to sulfoxide, which is further oxidized to form sulfone. But instead of hydrogen peroxide, we use nitric acid. It is a strong oxidizing agent. So directly sulfur is oxidized to sulfone. So next compound is sulfonol. So sulfonol means acetone diethyl sulfone. So this is the acetone part. This is diethyl. This is sulfone. So you named it. This is acetone diethyl sulfone or diethyl dimethyl sulfone. Okay. So next preparation from acetone and ethyl mercaptan. So acetone reacts with the ethyl mercaptan in the presence of acid to form diethyl dimethyl mercaptan. Here it is a condensation reaction because 1 mole of water is removed. So it is a condensation process. This is undergoes oxidation in the presence of KMnO4. Sulfur is oxidized to sulfur dioxide. So S is converts to SO2. So this is the sulfone. So you get sulfonol. So next sulfone. So that is R2SO2. It is the oxidation product of sulfoxide. So preparation, so alkyl sulfate, that is R2S, undergoes oxidation in the by using hydrogen peroxide. Sulfide is oxidized to sulfoxide. Sorry, it is the oxidation product of sulfoxide. So the sulfoxide is SO, which is converts to SO2. This is sulfone. So this is the oxidation product of sulfoxide. So alkyl sulfide oxidized by using hydrogen peroxide to form sulfone. So this sulfur is oxidized to sulfur dioxide. So this is sulfone, and water is removed. So sulfones are crystalline solids. It is used to characterize thioethers. சப்போஸ் உன்கிட்ட இருக்கிற காம்பவுண்ட் வந்து ஈத்தராக இருந்துச்சு அப்படின்னா ஹைட்ரஜன் பெராக்சைடு போடும்போது இட் கன்வெர்ட்ஸ் டு சாலிட். தட் சாலிட் இஸ் sulfone. So which is the characteristic reactions of thioether. So next, mustard gas. So mustard gas also thioether. So the formula is 2,2' dichlorodiethyl sulfide. So this is the sulfur atom. You give a number. So this is the first carbon, this is the second carbon atom. So this carbon is 1' and 2'. So in second carbon atom, the chlorine is attached here. So this is a 2,2' dichloro. This is the ethyl sulfide. Okay. So next preparation. So ethylene reacts with the sulfur monochloride to form mustard gas, and one sulfur is removed. So the reaction is so how it is formed. This is the 1 mole of ethylene. This is the another mole of ethylene. So here the bond is shifted here. So this gets positive, this is negative. Like that. This is the sulfur monochloride. So this Cl is removed as Cl minus, this Cl is removed as Cl minus, and also this sulfur is removed. So this Cl minus is added here. So it is CH2Cl. This Cl is added here. So CH2Cl, CH2Cl. So this sulfur atom is inserted here. So what is the product? CH2Cl, CH2S, CH2, CH2Cl. So one sulfur atom is removed. So second preparation is from chlorohydrin. So chlorohydrin reacts with the sodium sulfate to form mustard gas. Okay. So what is the first step? So CH2Cl, CH2OH. Here CH2OH, CH2Cl. Sodium sulfide. So here one among these two sodium, one sodium is removed as sodium chloride, and another sodium is removed as sodium hydroxide. So sulfur is inserted here. Okay. So this is removed as sodium hydroxide, this is removed as sodium chloride. So sulfur is inserted here. So what we get? CH2Cl, CH2S, CH2, CH2OH. This is reacts with the acid. This hydroxyl group is changes to chlorine atom to get mustard gas. So properties. So mustard gas is not a gas, it is a oily liquid. So the boiling point of mustard gas is 217 degrees centigrade. The gas smells is like mustard, so it is called as a mustard gas. So what is the uses? It is a highly poisonous compound, so it is used as a poisonous gas in a First World War as a chemical weapon. So when sprayed, so இதை நம்ம ஸ்ப்ரே பண்ணோம் அப்படின்னா vapor causes distress, itching and ulceration on skin. So this chemical weapon has also been used in Iran-Iraq war. Thank you.